So friends, in our MEP oral, there are some questions asked on the topic called freshwater generator. So I have covered all the questions related to this topic. So the questions are as follows: freshwater generator working principle, AirBrine Ejector working principle, precautions for operation of freshwater generator, reasons for loss of vacuum in freshwater generator, reasons for high salinity in freshwater generator, how to minimize scale formation, regulating the capacity of freshwater generator, freshwater generator leak test. Now moving towards our first question, freshwater generator working principle. So the basic principle of all low pressure freshwater generator is that boiling point of the water can be reduced by reducing the pressure of the atmosphere surrounding it. By maintaining a low pressure, water can be boiled at low temperatures, say 50 degrees Celsius. The source of the heat for the freshwater generator could be waste heat rejected by main engine jacket water cooling. So when this question was asked to my friend, so he replied the answer that the freshwater generator works on low pressure principle, and he explained the full detail what I have mentioned here. So now moving towards our second question, AirBrine Ejector working principle. It works on the principle of convergent divergent nozzle as it provides the Venturi effect at the point of diffusion. As the tube gets narrows at the throat, the velocity of the fluid increases, and because of the Venturi effect, its pressure decreases. Vacuum will occur in the diffuser throat where the suction line will be provided. When the seawater passes through ejector, it crosses through narrow convergent divergent nozzle which provides Venturi effect. At the throat, a narrow tube of air ejector, the velocity of seawater increases, and because of the Venturi effect, its pressure decreases. So, because of this pressure drop, vacuum will occur in the diffuser throat. So now I will attach one video with which I will explain you how this process is taking place. So when seawater passes through the ejector at the narrow throat, velocity of seawater will increase, but due to this the pressure drop will be there, and this is known as Venturi effect. So this is the area where the pressure drop will be seen, but here the velocity of the seawater will increase. Due to this decrease in pressure, the vacuum will be made, and due to this vacuum, the brine or air will suck in and move out, mixing with seawater. Moving towards our next question, precautions for operation of freshwater generator. Seawater pressure at the inlet of air ejector must be 3 bar or more. The pressure at ejector should not exceed 0.8 bar. Never start freshwater generator distillate pump in dry condition. Operate jacket cooling water valves to the freshwater generator gradually to avoid thermal shock to the main engine. Feed water to be supplied for a few minutes to cool down the evaporator before stopping. Never open the drain valve of evaporator before opening vacuum breaker. Otherwise, atmospheric pressure causes seawater inside to hit the deflector. So these were the some precautions which we should take care at the operation of freshwater generator. So moving towards our next question, reasons for loss of vacuum in freshwater generator. So these are the some points which are responsible for loss of vacuum in freshwater generator. So loss of vacuum can be due to condensate level is too high, excessive back pressure on the overboard side due to high draft upshift. This parameter affects the vacuum in freshwater generator to some extent. So this was the point which surveyor wants to listen. Vent left open, it can be due to the human error. Condensation not taking place properly because condenser tubes may be fouled or choked with mud. Condenser evaporator tubes are leaking. Nozzle is enlarged and wear down. Vacuum ejector nozzle partially choked. Ejector pump pressure is low, due to which vacuum ejector won't work properly. Air leakage in the system is taking place. Ejector pump efficiency drops due to improper maintenance. So for this leak test, I have attached one more slide at the last of this video, so please watch this video full. So these were the points due to which the loss of vacuum is there in freshwater generator. So moving towards our next question, reasons for high salinity in freshwater generator. Diminisher is not functioning properly or diminisher element may be torn out, carryover of seawater droplets, too high evaporation rate, excessive vacuum when seawater pump temperature is too low, seawater feed rate is too low, leakage in the condenser tube, when freshwater generator distillate water more than its capacity. So for all the leakage test of the freshwater generator, I have attached one slide which will be helpful for you. So please watch till last. So moving towards our next question, how to minimize scale formation. Scale formation in freshwater generator can be controlled and minimized by continuous chemical treatment. So there are some compounds or chemicals which are used for the treatment. So these are polysulfate compounds like sodium polysulfate with anti-foam is preferred by marine engineers and is extensively used on ships. Their trade name is different like Vectreat by Unitor, Amber Oil by Drew Chemicals. So these are the some chemicals which are used for the treatment of freshwater generator. So whenever this question is asked, what chemicals are used for the treatment in freshwater generator, so you have to tell it polysulfate compounds like sodium polysulfate. So moving towards our next question, regulating the capacity of freshwater generator. Capacity of a freshwater generator means the quantity of freshwater produced by it per day. The capacity of freshwater generator can be varied by reducing or increasing the amount of jacket cooling water to the evaporator. The quantity of jacket cooling water to the evaporator can be adjusted by adjusting the bypass valve provided. So there is one question asked in MMD that how will you regulate the capacity of freshwater generator? So we can just answer that we can adjust the bypass valve to adjust the freshwater capacity. So there are some more questions asked that what will you do when the temperature of seawater is high or temperature of seawater is low. So I will make you understand that what we have to do while these conditions arise. So during very low seawater temperatures, evaporation temperature can fall to a lower value. In that case, adjust vacuum adjusting valve to control vacuum inside the shell. Cooling seawater quantity to the condenser also can be reduced to increase the evaporation temperature. During high seawater temperatures, evaporation temperature can go up. In that case, increase the quantity of seawater to the condenser for reducing evaporation temperature. So as in our previous question, I have discussed that how to minimize the scale formation. So these are the conditions due to which the scale formation is there. Too high evaporation temperature can cause scale formation in the heat exchanger. On the other hand, too low evaporation temperature result in seawater carryover, which increases salinity of freshwater bodies. So these are the conditions which can decrease the capacity of freshwater generator to generate the fresh water. So moving towards our last question, freshwater generator leak test. So this is the question mostly asked in our orals and this will be not available in any book. So in freshwater generator leak test, first isolate the freshwater generator, close outlet of distillate pump, vacuum breaker valve, bottom blow off valve, feed water valve. Then connect one air connection to freshwater generator and give 1 bar air pressure in evaporator shell. Then apply soap bubbles solution on the joints. Packing, check whether bubbles are coming or not. The evaporator should maintain the pressure without bubble formation to pass leak test. So this was the leak test which is carried on freshwater generator. So this can be also carried by maintaining the vacuum inside the freshwater generator shell. So both methods are okay, but mostly this method is followed, in which we connect an air hose and we provide air and maintain a pressure of 1 bar. So friends, these were the questions which are mostly asked on the topic called freshwater generator. So hopefully you would have understood these questions, and friends, please like and share this video so that all can get this video, and please subscribe the channel Marine Help for